Welcome everybody. We have a next Open Virtualization Portal webinar. Today my special guest is Jaroslaw Stakun.
Hello.
Hello Jarek. We just spoke that we've been working in IBM 10 years ago. It was something like that.
That's when we met, yeah.
Yeah. So time passes really fast.
Yeah.
Time goes by.
Quickly.
We'll try in the next 30, maximum 40 minutes, speak about the OpenShift, and our goal to take our attendees from the starting point.
Yeah,
so
we start from the very beginning.
Yeah, start from the very beginning. So we don't know actually anything about the containers. So this is the first series of the webinar. So hopefully, if we have a good votes, we'll come back and talk about much more advanced.
Definitely, we should. Yes.
Yeah. So let's get started. Few words about you, my friend.
Okay. So.
Yeah, it's you.
Not really. Now it's better. Okay. So I'm Jaroslaw. You can call me Jarek, Jaro, depending what's easier for you. I work for over 6 years now for Red Hat as a solution architect. My main focus are middleware technologies and recently everything around containers, which at Red Hat means OpenShift Container Platform.
Okay, everybody see on the photo that you're working in a Red Hat. It's a really beautiful shirt.
But still with old logo.
Old logo?
Yeah.
Nah, but we couldn't have one because yesterday was officially? No.
I think it was 1st May, but nevertheless.
Okay, 1st May. So
we need some time to catch up.
And you're working on C, yes? So not only in Poland?
Yes, I do, yes.
Okay, lots of work in OpenShift world?
Oh, definitely. We have, now it's like one of the key topics for us, so we are doing our best to serve our customers.
About myself, I'm running the company called Storware. From the OpenShift perspective and the Red Hat perspective, we do building the data protection solutions for this kind of the platforms. But also in a free time, I'm playing with my band, with my 2 bands. I loved playing the guitars and being in the mountains with my family. You can find me. I'm quite active on LinkedIn. As many people saying that I'm jumping out from the refrigerator. But if you would like to catch me, just send me the private message on LinkedIn. So Jarosław. I will
depending where you are.
Yeah. So everybody's saying that the containers is a shining star right now. Yeah. So what's your definition of the containers?
Actually, the nice thing about the containers is that it really depends who you are and what is your interest. The answer might be different. So if you look purely from the technology standpoint of view, it is just a way how you package your application and you deploy it and run it very quickly and efficiently. But if you are, for example, operations guy, this might be for you a way how you can consolidate and automate your infrastructure. And if you are more like on the management level, you have more business, you are more business oriented, then it might be for you the way how you develop new ideas, how you implement DevOps, so the new ways of building the applications more efficiently and in more flexible way.
So if I'm more app guy, so it's all about faster deploy.
Yeah, packaging and
packaging. If I'm an IT guy, it's all about the consolidation.
Yeah, it's consolidation, automation of your infrastructure.
So, but what about the virtualization guys? They're saying, there's many topics about shall we virtualize or shall we containerize?
People say that containers are something that competes with virtualization. In my opinion, this is just another layer that you can build on top because virtualization is great to optimize your infrastructure, your servers, the utilization of your servers. Containers are more about speed of deployment and efficiency around
so we shouldn't say versus, we shouldn't think about to even combine it.
Yeah, I think so. That's at least this is also my experience that those technologies typically they coexist.
My friend right now, Marcin Kubacki, is on the Red Hat Summit and he's really keen to see the KubeVirt projects. So this is a totally opposite way how to visualize in the containers. But
this is something we can discuss probably on one of the subsequent.
Okay. So let's go forward.
Yeah, let's move on. So containers typically are the starting point. Then the next big thing is how do you build the infrastructure to manage your containers at scale. And nowadays, if you look for a solution for that challenge, you will probably sooner or later meet Kubernetes. So Kubernetes is a orchestration engine which basically can manage your containers environment or your landscape at scale. But Kubernetes is just kind of engine, so it is like heart of the platform, and basically the full platform you can see on the slide. It contains much more. I call them functional blocks. So you see here in the middle we have 2 blocks with Kubernetes, so the Kubernetes control plane and the execution environment.
So this is a pure Kubernetes, yes?
Yeah. So this is the pure Kubernetes. Of course, Kubernetes is a software, so it needs an infrastructure to run. So you have on the bottom you see the servers, networking, storage. Also on the top you see on the top left hand you see the load balancing layer. So these are all the infrastructure components that are needed by Kubernetes to run. And on the other side, there's a lot of tools to manage your containerized workload. So you have here another block where you can see the applications, and then all the infrastructure that is needed to effectively build and deploy your applications, and then to monitor, to aggregate the logs, and all those blocks you can see these are functional blocks, but there is one more component which is not really functional, but it's more like cross-functional thing, which is a security. This is something what we cannot underestimate. So if you want to put all those blocks together and you want to do it in secure way, to follow the security standard, to make the system really secure, it's not that easy. So, and this is basically where really OpenShift comes into the picture. So
if you're comparing the Kubernetes environment with the OpenShift, you're always saying that it's all not only about you have more blocks in a whole, but also really you're saying we cannot underestimate the security. So it's one of the packages inside.
Well, security is cross-component, so it spans all the blocks. So it is very important to have, this address here.
Okay.
And this is basically what is OpenShift all about. So if you recall all those blocks, if you put them together, and you remember about all the security standards, this is where you get the OpenShift basically. So OpenShift, it consists of four layers, like you can see here. It all starts with the operating system, which of course in our case is Red Hat Enterprise Linux. Then we run Kubernetes. So depending on the OpenShift version, we will run different versions of Kubernetes. And then on top we have all those tools, all those functionalities which I mentioned before. So for both application deployments, for builds deployments, and also for monitoring, log aggregation.
So to take in short, you're saying that it should be much more easier to deploy the application using the OpenShift than the native Kubernetes.
Yeah, it will be
because the third-party applications.
It will be because you have all those blocks put together, so you don't have to build.
You don't have to think about it, how to put it.
Exactly. You don't have to think about it, especially if security is your concern. You don't have to deal with that. You get just one system that covers all those functionalities, and you just focus on building, deploying, and running your applications.
Okay.
And then on top we have also
sorry.
No, it's okay.
Okay.
And also on top we have the huge library of container images that you can use to build and deploy your own applications, because it's quite similar like in virtualization. So we have an image and we have a runtime. So the same thing here. We provide images where you have different technologies, as you can see on the slide, starting from the different languages that you can leverage to build your application, to develop and build your applications, databases, and all the middleware stack. And also there is basically we are compliant with the OCI and with Docker, so you can really run any kind of images available on the market on this platform. And then we move on to just to quickly see what really is OpenShift from the architecture point of view. So you can see in order to deploy OpenShift, you will need basically a bunch of servers.
Sorry.
There are two kinds of servers. So you see the big block master. So this is the control plane of the cluster, and then you have worker nodes, and these are the basically the servers where you will run your containerized applications. OpenShift can be deployed anywhere where Red Hat Enterprise Linux can be deployed. So this could be either physical, virtual, or cloud environments.
So what was the favorite flavor in on a VMware, on a physical servers?
From my experience in general, I think the virtual environments are a good starting point. Because you can leverage your skills around the infrastructure management, and then when you grow at some point, typically customers, when they get more experience, they are moving slowly towards physical environments. But typically, virtualization is, I think, good starting
So
point.
the starting point should be the virtualized. Then, if we grow in and get better knowledge, going into the physical environment.
Yeah, this is at least my experience.
Okay.
Of course, some customers also prefer to start with some public cloud. So then, yeah, you don't have option, but this is like different story. Also,
lots of Microsoft is saying that you can run the OpenShift on Azure. It's lots of
definitely
information about it.
Even if you follow the summit conference, which is now taking place in US, the largest Red Hat conference, you might have heard that the new announcement about OpenShift managed service running on top of Azure.
Okay, no.
New thing.
Okay, new thing.
New thing that has been announced like yesterday. Okay, but OpenShift is not only about the servers; it's also about the networking and the storage. So we have also, as part of our OpenShift, the software-defined storage and software-defined networking. And now I would like to give you a very quick introduction and show you later in the demo how you can quickly deploy a new application in OpenShift. So as I mentioned before, what we need of course the container. So it means that you need to build an image with that container. So also we will need a place to store our images, and this component is called image registry. Okay. As you can see here, it also provides you the versioning functionality. Then the next thing is a pod. So basically, pod is a kind of wrapper on top of container. So in OpenShift, in Kubernetes, in reality, this is the main unit of deployment. So in OpenShift,
so you can see one pod can have a multiple.
Yeah, exactly. So there is one-to-many relation between a pod and containers, and there are good reasons for that. So if multiple containers they run in the same pod, they share the context, so they have the same networking, the same storage, the same memory. So the processes that are wrapped in containers, they see each other as they would be deployed on the same server. And as I mentioned before, we have networking in OpenShift. So each pod gets the IP address in the software-defined network that spans OpenShift cluster. And in order to deploy, to configure how OpenShift should deploy your pod, so what images, how many replicas, what metadata, what storage, and so on, we have a configuration object called deployment config, which is required to create a pod, but I will show you it can be generated very easily during the demo. And the next thing here is so we have two network layers. First one is called service layer, and with this service layer, you can implement the communication between the pods. So you can see here that if there is one pod that needs to communicate with the other pod, it will go via service. Service is purely network related object, so it has IP address, the DNS name, so it can be easily resolved by one pod to another. And the next layer, which is needed typically, is a routing layer. So with routing layer, you can implement the ingress from external from external systems which are running outside of OpenShift cluster. So if you want to expose one of the service to the public network, let's say, you define a route where you specify the host name of the specific route. And the last thing that is needed is a project. So with projects you can group or isolate pods in a logical manner. Also, projects are the main way to implement the multi-tenant environment in OpenShift. So with projects you can isolate not only the users but also the networks, the resources. You can attach specific pods or projects to specific nodes in your cluster. So this is the way how we implement multi-tenancy. And this is basically what I would like to show you now during the demo.
Okay, so let's grab the question till the on the end. Right now, let's move to the demo. So I will stop sharing my screen.
And I will start.
Yep.
Okay, so I hope you can see now my login screen. So I will use Web Console, which is also part of OpenShift. And I will show you how quickly and easily you can deploy containerized application in OpenShift, and also I'll show you a few other nice features. So first thing, if you remember, we need a project. So I will create a project just for our demo. Then we have multiple options how we will deploy containers to our application. So we can leverage here the catalog where we have a templates of different kind of applications. But in our demo, I know what image I want to deploy, so I will just select the name of the image. It is simple PHP application. With that, when I specify the name, the server will search for the image that meets the name in the registry, image registry. And now we can deploy the image. This should be pretty straightforward process. So you can see here that it has already started. And there was a couple of things that has happened in the meantime. So first of all, this deployment config has been created. So you can see that here is the name of the container that I wanted to deploy. You can see the ports that it exposed, and there are some more metadata that are created as well. We have a service here created, so now other pods in the cluster can communicate with our application, but you can see there is not yet any route created, so it means that at the moment this service is not reachable from outside of the cluster. So I will quickly create a route, which is also very straightforward, and with that route now I have the host name of my service, and I can access it from the public network. So
okay, so the route is the representation of actually the app deployment that you will create it, yes?
Yeah, this is the way how you can expose the application to the public network.
And the application are in a different pods, yes? It can be in one pod, can be in the multiple
yes,
pods?
Of course. Typically, you will have one application that consists of many pods, but only some of them will be exposed via services, and some subset of the services will be exposed as a route to the public network. Because typically you have some front and back end, so typically only front end is what you want to expose. And as you can see, just with few clicks we have deployed the application, and you can see here it is working. So the next nice thing about containers in general, but also about it is specific to OpenShift, is that you can very easily scale your application. So now let's say I want to run this pod in 3 replicas. So I scale it manually. You can see it has started very quickly, 3 instances.
So just double click, the high.
Yeah, exactly.
The icon, and you have already 3 pods.
Yeah, there is possibility also to automate, to have auto scaling here, so that the pods will be scaled
No, give the job for the operators. No, we just double click. But you replica, so you have 3 instances, not instances, 3 pods.
3 pods, yeah.
Okay.
And a nice thing about OpenShift here is that you see we have these 3 replicas, and those 3 replicas, they are deployed on different servers of my cluster. So this is something what takes a lot of time if you need to install your application in highly available configuration where you need to install multiple servers on multiple instances of your application on multiple servers, physical or virtual. Here you just simply scale up and automatically pods will be deployed on different nodes of your cluster. So we can see here the IP addresses of the nodes of the nodes where the pods are deployed. So they should be different. Yeah, and you can see they are.
Okay, but the major thing of the replica is not the only high availability. I understand that's also the load balancing thing. Yes. So if you would like to scale up.
Yeah, of course. I mean those 3 pods they are load balanced by the same service. So service acts here as a load balancer. If we go down here, you can see there are 3 pods registered in the service and in the root. So there are a lot of options here to implement things like sticky sessions and other stuff, but we leave it for maybe some subsequent discussion. Another thing I wanted to show is how easily you can migrate the versions of your application. So we have now deployment version number 1, so let's say the initial version, and now let's say I will simulate the upgrade of our application. So in real world, this would be triggered typically by deployment of new version of the image that is running our container. Here I will just quickly simulate that. So I triggered the second build, and you can see here how those upgrades are happening. So
let's imagine that we have a development team.
Yeah, but just follow the screen. You see that that the pods are being upgraded in the rolling
first one, second one, and third
in the
one.
Rolling fashion. So one by one they are exchanged, and now we have the second version of our application running.
And of course, if something goes down in a first replica, we'll not distribute it to the next one. Okay.
Of course, but also we can extend this this concept, and this is I think one of the last things I wanted to show you today. So you see here we have like 2 versions of our application, and if our application is running for some time and we realize at some point that there is something wrong and we want to roll back.
Okay, so some bugs in the application.
Yeah, exactly. Like that. Typically you will test your application before you will deploy it, but of course,
life is life.
Exactly. Yeah, there are sometimes some really like edge cases where when your application is running, you will discover something is wrong. And then you can see here OpenShift will keep the history of your deployment. So if you see that your latest deployment is not fine, you can simply click on the previous or one of the previous you have, and then you have here the magic button rollback. And when we click it, you can see pretty much the same thing is happening, but this time it will deploy the version that you have selected to be rollback. And again, it runs in the rolling fashion. So you see one by one pods are being redeployed. Also, you can implement here in the pods health checks. So OpenShift will execute some test after the new version of your pod is deployed, and will check if this test is passed, and only then it will allow to deploy a new version of your application.
Jarek, it looks too easy. Where are the pitfalls?
This is quite new thing, and new idea. I think there are no pitfalls. The biggest challenges here, is more around the how you organize your pipelines, your CI/CD. But this is something that probably we should discuss on the separate webcast. But I hope you like it, and you see it's quite powerful technology.
Okay, so again, coming back, remind us what are the key components starting from the scratch. So we have an image.
So first we have the image, yes, which is built by developers. Then we have basically a container, which is a runtime for image.
So actually the development team only cares about the image, yeah. So commit, build it, and rest should be on the OpenShift side.
Actually, even builds can be implemented here.
Okay.
We have a feature called source to image, which you can leverage to really build an image directly from the source code of your application.
Okay.
So you can even go further with the automation of your CI/CD.
So image, pod.
Yeah, we have image, we have container, then we have a pod, which is the deployment unit here in OpenShift. Then we have a service where we expose
our application,
or our module in the application. But this is exposure only within the OpenShift cluster. Then we have a root if we want to expose service to the public network, and of course we have a project. Yes, so where we separate our applications from each other.
Okay.
So these are the main components. There are of course much more configuration, but they are more specific to some use cases. So you have seen this deployment config here, where we have a definition of our pod. There are some other as well, but these are the key. Okay. Let's say
we said 30-40 minutes, and it's actually 30 minutes. So we have really good timing.
Yeah, I was doing my best.
What do you think? What will be our next webinar? When you would like to take our attendees?
Well, I think in general we think that you might have different opinion on it, but we believe this is mainly a platform for developers and for applications. So I think the next step here, the next topic that we should cover is how you implement your CI/CD process. So how you test and deploy your application from the source code, from the change of the source code up to the production. What should be the flow?
Okay, dog. So Jarek, thank you very much for the first session.
Thank you.
It was the next Open Virtualization Pro webinar with Jaroslaw Stakun. It was the one of the first season that will go through all of the OpenShift secrets. We just getting started. So Jarek, thank you. Appreciate your time.
My pleasure.
Thank you. See you. And right now we'll go to the questions. So if you have any question, just you can unmute, or you can just send on chat. We will be waiting a few minutes for it.